Welcome. Today we explore one of the most elegant ideas in classical mechanics, relative speed. Specifically, how objects behave when they approach each other, and when they move apart. Here is the core question: if two objects are moving each with their own velocity, what is the speed at which they are closing the gap between them, or opening it? Before we calculate anything, we need a reference frame, a fixed observer who measures all motion. From that observer's perspective, every velocity has a direction and a magnitude. Velocity is a vector, it has both magnitude and direction. We define a positive direction, usually to the right. Motion to the right is positive. Motion to the left is negative. This sign convention is the foundation of everything that follows. Here is the number line representation. Positive to the right, negative to the left. Car A moves right, positive velocity. Car B moves left, negative velocity. Always assign the sign before you substitute into any formula. Case 1, the speed of approach. This is when two objects are moving toward each other, closing the distance between them. When two objects move directly toward each other, their speeds add up. The speed of approach equals VA plus VB. Both magnitudes are positive, we add them because the gap is closing from both sides simultaneously. Here is the formal derivation. Define rightward as positive. Car A has velocity plus VA, car B has velocity minus VB, since it moves leftward. The relative velocity of A with respect to B is VA minus the velocity of B, which equals VA minus negative VB, giving us VA plus VB. Let us solve a numerical example. Car A moves right at 60 km per hour. Car B moves left at 80 km per hour. The speed of approach is 60 plus 80, 140 km per hour. They closed the gap at 140. Case 2, the speed of separation. This is when two objects are moving away from each other, increasing the distance between them. When two objects move directly away from each other, their speeds again add up. The speed of separation equals VA plus VB. The gap grows from both sides, the same formula, but this time the distance is increasing. Car A moves left at 50 km per hour. Car B moves right at 70 km per hour. The speed of separation is 50 plus 70, 120 km per hour. That is how fast the gap between them grows. Case 3, both objects move in the same direction. Now we subtract their speeds. If car A is faster, it approaches car B. The relative speed is VA minus VB. The gap closes at a much slower rate, only the difference in their speeds matters. Now we can state the general formula. The velocity of object A relative to object B equals the velocity of A minus the velocity of B. This single expression covers all three cases: approach, separation, and same direction motion. The sign of the result tells you everything. Here is the complete summary. The master formula is VAB equals VA minus VB. Case 1, opposite directions toward each other, gives a large positive approach speed. Case 2, opposite directions away, gives a large positive separation speed. Case 3, same direction, gives a small difference speed. This is not just theory. Every time two vehicles pass each other on a highway, relative speed governs the closing rate. Traffic engineers, collision analysts, and transport designers use these exact equations to calculate safe following distances, impact velocities, and response times. When solving any relative speed problem, follow 4 steps. Step 1, define your positive direction clearly. Step 2, assign signed velocities to each object. Step 3, apply the formula VAB equals VA minus VB. Step 4, interpret the sign of your answer. Positive means approaching, negative means separating. Relative speed is one equation, VAB equals VA minus VB, with 3 powerful interpretations. Master the sign convention, apply it consistently, and you can describe the motion of any two objects in the universe relative to one another. That is the elegance of classical mechanics.